Hi everyone. Welcome to our today's webinar. I'm gonna just give me a few seconds so to let everybody in. So yeah, as everybody slowly comes in, I just want to welcome you to our another Applied Pathology webinar series hosted by Animal Welfare Slack Workspace. My name is Jen. On behalf of Christian Aros, Laura Salazar, and Sebastian Gumon, we really thank you for joining us today. And this talk will be recorded, and it's being recorded right now, and then it will be available on our YouTube channel later. So before we start, it would be great if everyone can just double check your mic is on mute and your camera is turned off, just so that the webinar quality can be maintained well. And please type your question in the chat box, and we can go through them at the end of the talk. Or if you prefer to ask that yourself, you are also very welcome to raise your hand later. So today we're very excited. We have our actually second ever talk on turkeys. And our speaker is Domenica. And Dominica is originally from Ecuador. She moved to Canada 6 years ago to pursue her studies at the University of Saskatchewan. She completed her Bachelor of Science in Animal Bioscience and is now pursuing, actually completed her master's thesis in animal science. So today she's going to tell you a lot about her research, her master's research. So before beginning her master's, she worked as an undergrad research assistant in historical research. She has experience that broadened her academic perspective, but ultimately reaffirmed her long-standing passion for animal welfare. So throughout her graduate program, she has been recognized for her writing and communication, earning a lot of awards, such as the Cleve D. Carpenter International Essay Competition, and then she also selected for the 2026 World Poultry Congress Student Program, and she just recently won the AgBio 3-minute thesis competition. It's a great achievement. And in addition to her research, she has also contributed to teaching and multilingual science communication in both English and Spanish. And her work really reflects a commitment to accessible science and welfare and building meaningful connections between research and the communities it serves. So thank you very much, Dominica, for giving us this talk, and we're really looking forward to hear all about your research. The floor is yours.
Thank you so much, Dr. Chu, for the introduction. Uh, Thank you so much for the opportunity to be here today. Today, I would like to walk you through a little bit of my experience working on the effects of LED light wavelength and bit treatment on the performance and welfare of Nicholas electric hens. First, I would like to start with my outline. We will first run into the problem. Why did we choose lighting? My research, the results, and what it means for the industry, for welfare, and as a conclusion. The problem is that currently we have been using infrared treatment as a management tool to minimize injuries caused by aggressive pecking and cannibalism. Injuries as the ones showed in the picture. The literature suggests that infrared treatment doesn't cause pain. However, it has become a controversial practice due to pain, loss in the big sensitivity, and stress perceived by consumers. Due to consumer awareness, we believe that soon enough North American producers may face pressure towards banning this practice, which means that we need an alternative solution. Turkeys have a highly developed visual system with around 50% of their cranial space for their eyes. This gives us a little hint on how important the visual system is for them. In addition to that, the avian retina contains rod cells that are able to distinguish between low luminance condition and cone cells that are able to discern between different light wavelengths or colors. They are considered tetrachromatic species, which means that they are able to distinguish between red, green, blue, and the UV light wavelength spectrum. Knowing this, a lighting stimulus can go to the avian retina and deep photoreceptors in the brain. This in turn, which stimulate the hypothalamus to sympathetic signals to the pineal gland, which in turn will produce melatonin. Melatonin is a hormone that can stimulate locomotor activity, body temperature, and feeding activity. But why did we choose light color? Currently, we know that there is very little research done on turkeys, and the research available on light in color in turkeys is older than 40 years old. All of these studies use a photometric measurement based on human spectral vision or lux, rather than clocks, which is the measurement that we use, which is based on bird spectral vision. This clocks is used to measure light intensity. The light source that all of these studies use were incandescent bulbs with light filters. As I mentioned, there has been very little research done on turkeys, which is why I also look into the research done on broilers. Once again, most studies use logs instead of clocks, which is why I decided to separate between the studies that balance intensity with light wavelength and when intensity was balanced with light wavelength. The studies that didn't balance intensity with light wavelength were the ones that used logs, and the ones that balanced intensity with light wavelength were the ones that used clocks. When intensity wasn't balanced with light wavelength, we saw better feather condition, mobility, reduced foot path dermatitis, and lower stress levels. And the blue and green light source is the alarm from where I live. It's the monthly run. Sorry about that. When intensity was balanced with light wavelength, there was no effect on performance, birds were more farsighted, and there were lower activities and stress levels. Once we move into the research available in turkeys, once again, I want to remind you that all of these studies use logs and incandescent bulbs. This is important because once we look into the results, we see a variability in performance between green, blue light, and intermittent white light at different light intensities. We see heavier weights at 0.4 logs, but once we go into blue light, we see an increased weight gain at 5.4 logs, and then a faster growth at earlier ages. Sorry, I'll just move my set for a little bit. Okay, I hope that's good. And then we see intermittent white light at 86.1 logs, which in other lighting programs. For behavior, once again, we see a repeated pattern with lower activity levels at low light intensity, 5.4 logs, but also lower activity levels at 86.1 logs. And then when we had an intermittent white light at high intensity, we see hyperactivity and extreme flightiness. In health, there wasn't a lot of research, but the one available suggested pure feather condition at 86.1 logs. And under green light, there were higher mortality at 0.4 logs. In addition to that, I also mentioned Jen, I'm just gonna check that out really
Yeah,
quickly because
yeah, sure.
if not, it's okay. I will go quickly to uni and then give the webinar from there. If
Okay,
that's
okay, okay,
okay.
sure.
Just
So
give me,
you
yeah, because the
okay,
alarm, I think it's been disturbing for everyone.
okay.
Or are you hearing the P from the
We
alarm?
can't hear it, but then yeah, you should do whatever is best. Yeah,
Okay.
we can wait a little bit.
It is stop. So I hope it's the
It's a
last one.
test. Okay,
Yeah, it's just like the monthly test they do. I don't know why. But anyway,
okay,
okay.
okay.
Yeah, I think I can you hear that?
No. We cannot hear
Okay,
anything.
okay, then if you cannot hear it, that's fine.
Okay.
Okay.
You are safe, right? Okay. As long as you're
Yeah. No,
safe.
it's
We don't
just
want
like the
you to
test.
give the
Yeah, sorry
webinar in
about that.
danger.
Okay.
Okay,
Yeah.
no problem.
Yeah.
Thank you.
Yeah. So why did I mention also that they use incandescent bulbs? It's because currently LED lighting is more used and they are easy for dimmability. There are no toxic chemicals and gases, and they are also more energy efficient, producing around 90% at visible light compared to only 10% as visible light produced by incandescent bulbs. So to sum up, there has been a clear understanding on LED lighting in broilers, but what about LED lighting color in turkeys? So I will move into my research. The objectives were to investigate the effects of different LED light wavelengths and big treatment on the performance, health, and welfare of turkey hens reared up to 11 weeks of age. My overall hypothesis was optimizing different light wavelengths as a management tool will enhance the welfare, performance, and overall health in infrared big treated or sham treated turkey hens, preventing or reducing aggressive behaviors and improving overall productivity. To test this, I used three light colors, blue, green, and white. Blue peaking at 455 nanometers, green peaking at 510 nanometers, and white a combination of wavelengths. For big treatment, we also wanted to use big treatment because we wanted to see the effect that lighting will have when turkeys were infrared big treated, but also when they have their intact beaks. Throughout this seminar, I will refer to infrared big treated as IR and for sham treated as sham. What is infrared beak treatment? Infrared beak treatment refers to the process turkeys or poults go through at the hatchery. They are put in a machine that targets the upper part of the beak and with an infrared light. And then 2 weeks post-treatment, the upper part of the beak sloughs off and they have a different shape in the beak. As shown here, they don't have the sharp hook of the beak. Instead, they have the upper part of the beak slope off 2 weeks post-treatment. For housing, I had my rooms divided into two pens, as you can see depicted in this diagram. In addition to that, you will also be able to see the dimensions of my pens. I housed 2,916 turkey hens per trial with 162 hens per pen. At the end of the trial, I had a final stock density of 45 kilograms per meter square. This is a picture of how my pens look in real life. Lighting, which was an essential part of my experiment, we assessed the lighting spectrum on day 0 and day 7 with a light meter. My lighting program went from 23 hours of light and 1 hour of darkness to 18 hours of light and 6 hours of darkness by day 7. My light intensity started at 40 clocks and then it decreased gradually to 10 clocks by day 7. I use a Galilux light meter to assess light intensity once a week. To assess environmental conditions, we also measure the leader quality. And I use a scoring quality technique used by the Welfare Quality Consortium. And I assess the leader quality in the 5 locations depicted in this diagram, with 0 being dry and flaky and 4 being compacted and crusted. This is a 3D diagram of how my pens look like. The camera position, the light bulbs, the feeders, the drinkers, and the feeders. We had, as you can see in this diagram, the only difference between my pens were the lighting color. For my data collection, for day 0, we measure arrival weights, and then from 3, 5, 8, and 11 weeks, we measure body weight, feed consumption, feed to gain ratio, heterophil to lymphocyte ratio. This was done, the heterophil in lymphocyte ratio was done in a subsample of 15 birds per pen, which were randomly selected. For flock uniformity, we also assessed the weight individually in a subsample of 20 birds per pen, which were also randomly selected. Furthermore, at 3 and 8 weeks, I measured behavior. We recorded 24-hour continued period of their behavior. And then I perform a scan sample technique at 20 minutes intervals after the behavior were recorded at 3 and 8 weeks. Just to give you a little insight on how long it took me to look into these videos, it was around 3 to 6 months because I assess a wide spectrum of behaviors, comfort behaviors, aggressive behaviors, activity, mobility, amongst others. At 10 weeks, we also measure ophthalmological parameters in a subsample of Forsberg per pen. And then at 8 and 11 weeks, I measure gait score, footpath score, feather condition, and cleanliness. We also continuously monitor their health, so we conducted health check-ins twice per day. We also assess their aggressive damage and their mortality. For aggressive damage, we recorded the incidence, the location, and the severity of damage. For mild damage, we use a deterrent or pine tar, which we consider an anti-pecking solution when it works. Mild damage as the one depicted in this picture, where there is damage to the snout, so we will put some deterrent in this part of the gun. And then for moderate damage, as the one depicted in this picture, we removed these turkeys immediately from the trial and we took them to the hospital wing, which was some pens assessed for some pens that we set up for turkeys that will suffer aggressive damage. And then for severe damage, as you can see in this picture, they were euthanized immediately. I also conducted an economic analysis, consider input and output values. For input values, I consider the numbers of pool plays, the pool cost, the feed cost, and for the output values, the bird income. For my statistical analysis, I conducted a randomized complete block design, and my ANOVA was conducted using 3 light wavelengths and 2 big treatments in a factorial arrangement. I also evaluated interactions, and my data was analyzed for normality and block transformed when needed. The mean separation was done via Tukey's test, and the difference were considered significant when the p-value was lower or equal to 0.05. Now moving into the most exciting part of my research, where are the results. First, I will start with light color. First, I will start with 50-gain ratio when was corrected for mortality at between 3 to 5 weeks. And as you can see, the fit to gain ratio was better under blue light compared to green light. Once we look into their behavior, we did see that they performed less aggressive pecking under blue light at 3 weeks compared to green light, which can tell us that there was less energy spent of aggressive behaviors. In addition to that, once we move into feed consumption between 8 to 11 weeks, we see that the highest feed consumption was under blue light. But once we move into the body weight gain at the same period, we see that also it was the highest under blue light. A possible explanation could be the influence of blue light on growth hormones and at IGF-1 and androgen production as shown by previous researchers. For aggressive damage, and I am really excited about this. As you can see in this graph, there was no incidence of aggressive damage under blue light, and also no cannibalism under blue light compared to green and white. So what does this mean? As you might remember from the introduction slides that I showed, we see that we try to diminish injuries by using infrared big treatment. But what blue light did is that we see none of these injuries under blue light. So blue equalized no incidence of aggressive damage. Another thing that you might have noticed in this graph is that the incidence of aggressive damage was also lower in green. A possible explanation is that even though there was a higher incidence of aggressive pecking at 3 weeks, once we look into their behavior at 8 weeks, we see that under green light there was actually a higher incidence of exploratory behaviors. These exploratory behaviors include environmental pecking and gentle feather pecking. Once we move into behaviors at 8 weeks, we did see that turkeys under blue light were resting more and walking less. A possible explanation to this could be the influence of blue light on circadian rhythms through melatonin regulation. Once we look into the average score of litter quality, we did see that it was worse under blue light, and also a higher incidence of footpad lesions under blue light. The scoring system that we use to assess footpad lesions is the one depicted in this diagram, and we also see that they were dirtier feathers under blue light. How do all of these connect? Is that because there was reduced activity under blue light, there was a limited litter turnover, which means there were a higher incidence of footpad lesions and also dirtier feathers. Now, something that we didn't expect to see is an abnormal behavior that developed under blue light. Please pay careful attention to their necks in the videos that I'm gonna display. As you were able to see in the videos, the turkeys move their head backwards and then in a semicircular motion. There has been no literature recorded on this kind of behavior, which is why we decided to denominate it as cervical retroflexion. It was only present under blue, and I do want to emphasize that a number of birds that we saw per trial depicting this abnormal behavior were 6 in the first trial and 5 in the second one. The physiology remains unknown. We did consult with veterinarians and producers to see if they have seen something similar, but despite consultation with them, we still don't know the physiology behind this cervical retroflexion. At 11 weeks, by the end of the trial, we did see that there were lower stress levels under blue light. A possible explanation is that there was no incidence of aggressive damage under blue light, so that could have led to lower stress levels. To sum up, under blue light, we see better productivity, lower stress levels and mortality, but bad footpad health and dirtier feathers. Under green light, we see moderate aggression but more exploratory behavior, and the worst results under white light with no effects on performance, a higher mortality and higher aggression. Now I will move on into my big treatment. For feed consumption between 3 to 5 weeks, we see a lower feed consumption for infrared big treated hens. However, once we look into their nutritive behaviors at 3 weeks, we actually see the opposite. We did see that infrared big treated birds spend a higher percentage of their time performing nutritive behaviors, which gives us two possible explanations. Once the turkeys go through infrared beak treatment, they go to an adjustment phase to the new shape of their beaks. Or it could also mean that sham-treated hens spent a higher percentage of their time playing with their feet, which led to a higher feed consumption. Now, moving into feed-to-gain mortality, we did see that infrared beak treated birds had a better feed to gain mortality between 0 to 3, 3 to 5, and 5 to 8 weeks, which actually tell us that there was less feed wastage for infrared beak treated birds. We did see difference on wing damage, with infrared beak treated birds showing zero aggressive damage on wing between 0 to 3 weeks. A possible explanation is that once we look into the total aggressive behaviors around this same period, we did see that infrared beak treated birds spend less percentage of their time performing total aggressive behaviors compared to sham treated. Because the infrared beak treated birds had a different shape of their beak, that leads to a decreased pecking effectiveness, reducing the incidence of injuries. We did see that IR birds spend more time walking and less time resting, which could also be a redistribution of time budget, as aggressive outcomes were less rewarded. And once we move into the behavior at 8 weeks, we did see that infrared big-treated birds spend more time frolicking, which is a positive behavior associated with playing and positive affects. Once we move into a feather coverage, we did see that the birds that we assessed had a higher incidence of score 3, which meant that less than 50% of the plumage was missing for infrared big-treated birds. But once we move into score 4, we did see that for sham-treated hens, there was a higher incidence of score 4, which is full intact plumage. Because they have a different shape of their beak, this could be that they have a different shape of their beak, so they were less effective at preening. But I do want to point out that there were small differences between infrared beak treatment compared to sham treated. Now, and when we move into the tail feather coverage at 11 weeks, we did see that the sample birds that scored 4 on tail feather coverage, was a higher incidence of full intact plumage in infrared beak treated birds compared to sham treated. The tail area is a vulnerable area that usually turkeys target during aggressive interactions. So the fact that we see a better plumage coverage on their tail at 11 weeks, it means that there was a reduced impact for infrared beak treated birds compared to sham treated. We also see a reduced incidence of skin tears in infrared beak-treated birds. Once again, because the shape of the beak was different, they was less effective at grasping the feathers and tissues from other birds. For infrared beak-treated, we see improved feed efficiency, less aggression at 3 weeks, less in skin tears, more playing, and purer net feather coverage. In sham treated, we see actually the opposite and also purer tail feather covers. Now I will move on into my interactions. In my y-axis, you will be able to see the percentage of birds placed. In my x-axis, the infrared beak treatment and sham treated, and the lighting colors will be represented by blue, green, and white. As you can, first I will start with infrared beak treatment. There was no difference between lighting colors. And for the same with sham treatment, no differences between lighting colors. However, when we compare infrared beak treated white with sham treated white, we did see that there was a higher incidence of infectious diseases with infrared beak treated white compared to sham treated white. Moving on into metabolic diseases, this interaction was a bit more complicated, so please stay with me. First, I will start with the infrared beak treated group. As you can see, there was a higher incidence of metabolic diseases under green light, followed by white and then blue. Moving into the sham-treated group, we see the opposite, a higher incidence of metabolic diseases under blue, followed by green, and then intermediate response under white light. Once we compare each lighting wavelength between big treatments, first, when we start with blue, we did see that under blue light, the incidence of metabolic diseases was higher in sham-treated under blue light compared to infrared beak treated under blue light. And then we see the opposite effect under green light with a higher incidence of metabolic diseases under green light for infrared beak treated hens and a lower incidence of metabolic diseases for sham-treated hens under green light. There were no differences under white light. Now, once we look into the total mortality, and this is actually something quite interesting, is that the lowest mortality was, once we combined the light wavelength with beak treatment, the lowest mortality was under blue light combined with infrared beak treatment, and the highest was for white light combined with infrared beak treatment. This is important because once we look into the numbers of bird shaft, we see the opposite, a higher numbers of bird shaft under blue light compared to white light. What it means is that the best management option to reduce overall mortality in turkey flocks was the combination of blue light with infrared treatment. And this translated into my economic analysis. This is important because we did see a higher income per bird in blue light compared to green light, with a difference of $1.04 Canadian dollars. And once we look into the real life setting, which is around 16,000 birds per barn, it's a difference of $16,000. And once we compare blue with white light, there was a difference of $1.47 per bird. Uh, and once we look into a real life setting, it's a difference of $23,000. Now, what will it mean for in as conclusion? Under blue light, we did see cervical retroflexion and some compromised welfare aspects, but we did see improved productivity outcomes and no aggressive damage, which means that we need to balance out. If we are applying blue light, there should be really a careful management of the litter quality and the health of the footpath and the dirty feathers, as dirty feathers can also impact the insulation and temperature regulation of turkey hens. For green light, we did see intermediate outcomes, and for infrared peak treated, we see a better feed efficiency, less skin tears, and the interaction between infrared peak treatment and blue light was a mitigation of mortality. I would like to acknowledge the founders of the research, and I am happy to answer any questions.
Thank you very much,
Sorry.
Domenica. Very clear presentations, and yes, thank you so much. So, we have currently one question for the audience. Anna is interested in the deterrent you mentioned when they're doing the aggressive packing. So she's wondering what's what is it made of? Like, because she never heard of this product before.
So it's pine tar. So it's like the from the tree, the from pines. It's like a sticky material that you can buy it in stores. It's usually for the floors, but from the barn staff, in previous turkey trials, what they notice is that once they put it in the injuries, it usually dry up the injury, and in addition to that, because the injury is dry, the other turkeys in the flock lose interest in pecking at the injury. But sometimes it works, sometimes it doesn't, because sometimes when they have the pine tar on the injury, they still peck at it. So yeah, it's kind of like a attempt to diminish the pecking, but usually they peck again. That's why we also assess the incidence, because we wanted to see if the same bird was pecking again. So yeah.
Thanks. And yeah, just also a reminder to the audience, please feel free to put your question, drop your question in the chat. So Anna has another question. Would you consider inactivity as a welfare indicator to be assessed under blue light? And what would you propose to encourage positive behaviors under blue light?
Yeah, I do consider that reduced activity is a part of a welfare assessment. However, when we look at the full picture, for example, when we analyze stress levels, we did see lower stress levels under blue light. But I do think that further research should consider maybe a mixed lighting spectrum between blue and green light, so that there is because as I showed, there was encouragement of exploratory behaviors under green light. So maybe the combination of blue light with green light, and also the use of enrichments under blue light. Something really curious that happened under blue light is that my shoes were pink, and under blue light they were really bright. So they would like to peck at them and like follow them around, and then they will actually move a lot. So some kind of enrichment that will call their attention, I think, will be nice to see if that actually increases their activity levels under blue light.
Yeah, so this actually relates to Anna's second question, like
Mhm.
how do you propose to encourage positive behaviors in
Mhm.
blue light? So you would
Yeah.
say like enrichment, yeah.
Yeah, enrichment and hopefully future research on mislighting spectrum, like the combination of blue with green, will be nice to see. Yeah.
Great. Christian also has a question also related to the spectrum you were talking about. So you mentioned that blue light in particular might have triggered some physiological effects, but
Mm-hmm.
blue is part of the white light spectrum. So what part of the rest of the spectrum could have led to an increase in aggression and why? Maybe thinking of a reflection on the plumage or similar. Yeah.
Yeah, so actually that's something that we consider when we what we were mainly thinking of is that maybe the because white has green and blue, but blue has more of the UV spectrum and blue doesn't have the green part, or as green will have the blue part. So when we compare the lighting spectrum, I think that we mainly focus more like what will be the absence that blue doesn't have compared to white, that actually decrease the pecking activity. It could also be related to the fact that usually under blue light there is more UV compared to white and green. So definitely something to look at in the future. More UV lighting as well, I think. Yeah.
Great. So Sarah is asking, do you suspect this could be translatable across other bird species?
No. Part of my research was I did look into the research of broilers, but if we look back, the differences in broilers even in performance were kind of different from turkeys. So I like to view it as like cats and dogs, that the difference is quite different because under blue light broilers and turkeys both had less activity levels, but once we look into other aspects of their behavior or of their performance, their response was quite different. So I think that the difference between species, even within birds, can vary. So it would be important to see within each species what will be the response to blue light. Yeah.
Yeah, this is very interesting. I think, yeah, because usually we think of poultry as a whole big group, but
Yeah.
actually within them
Mhm.
there's still such nuance. And then so, maybe yeah, we talk about this like the clocks, maybe the turkey clocks will be also a little bit different than the
Yeah.
normal. Yeah, right.
Yeah.
So yeah,
Yeah,
definitely
exactly. Yeah.
more research. And I'm also curious about the mortality and culling rates. What were the main causes?
Yeah, so we did assess the cooling and the mortality separately. The mortality was actually quite low, but when we cool, especially when we do research trials, we are very picky when we are cooling the birds because we emphasize welfare a lot, so we don't want any bird like if there is lameness or if there is any a sign that they might be in pain, then we call the birds. And then they were sent to a diagnostic lab, and then we got the mortality causes. There was a wide range of mortality. Mainly as they grew older, it was lameness, so valgus varus or tibial dyschondroplasia, but all of these incidents were quite low. There was mainly cooling due to aggressive damage in most of the pens. Yep.
Thanks. And Anna is also asked another question about. I'm also interested in this question. So because she's asking how prevalent was the cervical flexion. If I can add on to Anna's question, because I remember you said that you actually asked, consult the producers, and did they actually see anything in the normal commercial practice, and how prevalent is that?
Yeah, so yeah, when I talk with producers, they did see something similar, that the birds will like just stood there and maybe not move as much, but not the movement of the neck going backwards and then in a semicircular motion as the way I saw it. So something interesting is that, and I didn't mention this, but once we took them to white light, because we removed them from the trial, from the blue light, and then we took them to white light, they recover. So after a few days, they were actually normal. Like they wouldn't have the movement of the neck backwards, and they were able to eat. We do consider the cervical retroflexion something important that research should look into, because once the birds developed that movement of the neck backwards, they weren't moving as much, so other birds will trample into them. So that's why we also removed them from the trial, because we didn't want other birds trampling into them or them losing weight and don't be able to drink or eat. So, yep. Hmm.
Great. Yeah, I think definitely we need more research to look into, yeah,
Hmm.
this behavior. And I don't know, Domenica, if you also want to share, because I know that you did a lot of investigation into different possible causes for
Yeah.
this behavior. Yeah.
Yeah, so we had some people from Purdue who took brain samples of these birds and also brain samples of my birds, and there wasn't like a disruption of serotonin levels or melatonin levels. So what we did think about is on the mandibular system, which I feel it's the closer explanation. And it's because in humans there is a similar disease in which is triggered by blue light, in which humans develop ataxia. So like they also have this thing of like they cannot move their neck. They don't move their neck, but like they have the position of the head upwards, and this is only seen in humans, and is also triggered by blue light. So that's the closer explanation that I could get to, because of the maybe something with their balance, something with their eyes, because their eyes and the blue light was actually bigger. Because of time, I didn't show those results here, but the eyes of the turkeys were actually bigger under blue light, and they were a bit heavier. The medial lateral diameter was actually larger for under blue light for turkeys. Yep.
Mm-hmm. I'm going to
Mm-hmm.
jump first to Sarah's question. I think you mentioned that already, Domenica, but maybe you can elaborate again. Did the cervical retroflexion resolve when exposed back to the prior lighting exposure, or was it permanent?
It resolved. We remove the ones that developed the cervical retroflexion to the turkey wing that I mentioned before, and there was white light in this turkey wing, and they didn't. They recover after a few days. They stopped showing that behavior, and they were actually normal, like they were behaving normally. Mm-hmm.
Cool. And Chloe is asking, do you think this could be used as an emergency reactive response to packing in systems with natural light, where natural light can be controlled?
Um, so if this could be an alternative to natural light, or why, what
I
do you
think
think?
I think Chloe probably said, yeah, we normally just use natural light, but then when
Mhm.
there's packing, aggression packing happens, then we switch emergency, to the blue light to calm them down,
Mhm.
and then switch back to natural light inducing. That's a possible option.
I think because in my trial the birds were in the under blue light from the time they like from when they arrived, like they were 1 day old from the hatchery. So, and they until the end of the trial, so they were always under blue light. So that's the response when they were always under blue light. So I don't know what impact it could have on them if they are receiving natural light and then suddenly they go into blue light. I don't know if that could be counteracted, because I think that poultry are very sensitive to changing environmental conditions. So I don't know if they might actually have an aversive reaction to that change. So I don't know if I would recommend that if you are using natural light, then change it. I think it's more feasible like in the intensity system and the intensive production settings that we have here in Canada, that they don't have natural light, so all their lighting is controlled within the barn. So we can actually introduce blue light in their lighting system. Mhm.
Makes sense.
But
Yes, the long-term exposure compared to the short and sudden change, it may
mhm.
actually end up having different results. Okay,
Yeah.
so
Yeah.
Chloe also asked, why did the study only look at hands, not stacks as well?
Mhm. So we decided to look first at hands because they are the more produced here in Canada. There is not as much production of toms. But I do think there should be the response in toms can be different from hands, right? Especially because they have a higher testosterone levels. So it will be important to look into others and into toms compared to hands. Yeah.
hmm And Chloe
Mhm.
also asked, do you have a definition that could be shared for frolicking?
For frolicking, yeah, so we define they will frolicking was when they will open up their wings and they run in the pen. So like they open up their wings and it's a bit funny. I could have I think I should have shown you a video, but like they just run in the pen like a how they will normally run in a pen, but like they open their wings and they it's kind of a playing like they play between birds like one bird will start doing that and then the other bird will follow and then some of them start doing that. So yeah, it's that behavior. It's the bird run with the wings open. If they were standing or just walking, then it's not frolicking. Yeah.
hmm
Mhm.
And do you think stocking density reductions might also impact your results?
My stocking density was actually resemble the production settings here in Canada. That's why I had a 45 kilograms. Um, it could be a bit different, the results depending on the stocking density as well. But according to the parameters that we have here in Canada, we did have a highest, not high stocking density, but the one following the codes of practice. So it resembled the production setting of how many birds will you have per meter square. So
Mm-hmm.
mhm,
But
mhm,
but do you think, let's say, if we go with less or even I
mhm.
hope not more, less stocking density, the results may change a little bit, or yeah, what would you assume?
Uh, I did under blue light, I think they will be quite similar, just because under less Samiha, who was also in Dr. Sharon Ladner lab, she did a lower stocking density with turkeys, and she saw lower aggression levels when there was a lower
Mm-hmm.
stocking density. So a combination of both can actually, I think, possibly exacerbate the result, and like there will
Mm-hmm.
be even less aggression, but because there wasn't even aggression under blue light, maybe under green light there will be even less aggression because there was like a
Mm-hmm.
the response under green light, but then if there is a lower stocking density than that,
Mm-hmm.
we'll have a stronger response. Yeah. Hmm.
Thanks. So I don't see yeah, there's no new question, but then like Anna, Chloe, Christian, Sarah, all thank you for your answer, and they all think that it's a very interesting study, and
Oh, thank you.
definitely a lot of further research is can be developed after following your study. And then Chloe, yeah, like Dominica has her email there because she said that she's interested to exchange further with you. So definitely, have a note of Domenica's email. You're very welcome to continue the conversation offline. And also, Dominica, this Dominica now finished her master's degree, so she's actually actively looking for a position. Also in research, if anybody knows about some, yeah, because you can see that she's really passionate about poultry research. So if you know any positions available, please also get in touch. She'll be very happy to hear about any potential positions. So if there's
Yeah.
no more questions, thank you again, Dominica, for your lovely presentations, and then
Thank
for
you
the
so
audience
much.
for your great questions. So we're going into our summary. summer break. Our next webinar will come back in September. But yeah, thanks to everyone for joining today. And then thank you again, Dominica. And then good
Thank
luck
you so much.
with job hunting and everything.
Yeah.
Yeah.
Thank you so much. Thank you so
Thank-
much. Yeah, and if you have any further questions, please feel free to email me. I am also in LinkedIn. So if you have any questions, just send me a message and I'm happy to answer any questions you may have. Yeah.
Great. Thank you. Have a lovely evening and a day for other people. Thank you.
Thank
Bye.
you. Bye.